marked and numbered. So we have T2 coming out of the compressor. Then it goes in to the condenser, and that's where it will exchange heat with the water that is coming from the pipe system, okay? So as it leaves the condenser, it's now at state 3. Again, this is marked here, so this is T3. All of these are only for refrigerant. Okay, so the refrigerant then comes in, and it goes into this flow meter. This is the... Hey! So this is the refrigerant flow meter, okay? So we now measure the refrigerant flow rate before it goes into the expansion valve. So we have the expansion valve right here. So T3 is the exit of the condenser. That's the temperature you have. And then you measure the flow rate. And then after it leaves the expansion valve, you're now at state 4. Again, this is coded and numbered here, okay? So you have T4. Now at T4, again, if you remember from the cycle, it now goes into either one of these evaporators. If you're on the water evaporator mode, that means it will go into this guy. Come see, this is the water evaporator, which is well insulated again. It's insulated so that you don't have any heat loss. There's only going to be a heat exchange between the refrigerant and the water. So after it leaves the water evaporator, it now goes back to here. It becomes state 1 again, okay? So it's state 1, 2, 3, and 4. And you can basically measure the temperatures.
Just not that, so. Okay, cool.
Yeah. So let's power it on, and we're going to keep it on water evaporator mode first. When we're done, we're going to switch back to air evaporator. So first, we just open the valve for the main valve for the water, yeah, that one, and then also the one for this experiment. So there are 2 branches. That one is going for the heat exchanger. Don't touch that. So we have the water flowing into the system. Now these 2 flow meters, close it. No, just the second one. Just leave. Okay, yeah. See, these 2 are flow meters. They have a floater that are showing you the flow rate in the mass flow rate in gram per second. Okay. The way you're going to read them is that you're going to lower yourself down so you can look at it in horizontally, so you can basically see the top part of the floater. That will show you the actual flow rate. Okay. Now turn it on. See these 2 flow rates. Okay, so now you have flow. And can you read what is the flow rate right here? The condenser flow rate?
17 and 0.8 or 0.9.
Don't do decimal. I mean,
Just 17.
Yeah. Even just 17 is hard to.
18 now.
Yeah. Okay. So what happens is that on the day of the experiment, one of the team leaders will stay here to make sure that the student is reading correctly, and then the student will tell it out loud. But the one who is putting in the computer, you should also make sure that that guy is also putting in that value correctly, because there might be a mistake or they might not hear well. All right. So now that we have water flowing, we're going to turn on the system. So first we did that. Now we turn on the system. Now again, as I mentioned, we're going to stick to 2 basically constant flow rates for both the condenser and the evaporator. But that depends on the water pressure and water flow rate that is coming in from the central system. Again, we want to avoid having any bubbles. Here for the refrigerant, it should be completely subcooled. So at all time, one of the leaders is always looking at this thing, and you're going to explain to students why you want that. You don't want any bubbles to go into the expansion valve. So as soon as you see any bubble, that means you have to change the flow rate. So for now, we're going to stick again with 30 gram per second for the condenser and 45 gram per second for the evaporator. Okay? But if we saw any bubbles, we're going to reduce down the flow rate. Again, we don't want to play with these a lot, because every time you change the flow rate, you have to let the system reach steady state. Okay? So we're going to do 1 run, but we're going to collect 5 sets of data to make sure the data is steady state. But we're not going to play with these a lot. If we have basically a good setting. We're going to stick with that, and we're going to keep collecting data. So we have 5 different readers. So let's, and again, you use these knobs to tune this. We can increase the flow rate. Okay? So let's put this on 30, and let's keep this on 45. Again, if you saw any bubble, we're going to tune these down. For now, this is what I mentioned in my slides. We're going to keep this at 30 grams per second and the evaporator at 45, around 45. Okay, so this knob, by turning it, this is now showing you T1, okay? It's just as simple as that. You do this, this is T2, T3, T4, T5, T6, and you have until T9. Those are the only temperatures you need for this one, okay? So let's go back to T1. And then what this one is showing you is the power consumption, okay? Now we're operating in the water evaporator mode. That means the entire power is being consumed by the compressor, okay? And how much is that?
500 watts.
Yeah, give or take. Again, you have to try to be more accurate. You're not going to use decimal. These are analog, so I mean, you're not going to say 500, 550 point whatever. You're not going to use decimal, but I'm going to say it's 500, maybe a little less, 495 or something like that. And this is in watts. And then you also have 2 pressures. Which one of the 2 pressures are lower? Evaporator pressure or condenser pressure? Evaporator. This is the evaporator pressure on the right, and you see it's given in kilonewton per square meters, okay? So you have this in kilonewton, and it is around what? It's like 225? 220, 225? Yeah? And then this is the condenser pressure. Obviously, it's higher. This is the higher pressure we're dealing with. So you have the PL and pH, the low and high pressures, and the 4 temperatures, T1, T2, T3, and T4, which you'll use to get the 4 enthalpies, H1, H2, H3, and H4. And then for the water condenser, you need the T6 and T7, okay? And the flow rate to calculate the heat that is taken in by water, in the water condenser. And then you're going to use the evaporator flow rate and T8 and T9 to calculate the heat that is given out in the water evaporator, okay? Now you see we have bubbles. We want to avoid that, so we're going to tune this down. Let's go to 20. Okay? Bubbles are gone. Okay? So as it's reaching steady state, you saw we weren't able to basically drive it down to subcooled, so it was giving us mixture. We don't want that. We want it to be subcooled, completely subcooled, 100% liquid. So we had to basically tune this down, so we're now at like, whatever, 20. Okay, put down your phones. We're gonna